Hello students, welcome to Short classes. Today's video is on ISI 2020 question paper subjective segment. As we know, the Bstat and Bmath has the same paper. So I will be concentrating on the first question. This I be the root of the equation. There is a given x square plus 1. Obviously, by this equation we get to see that the equation will give you the way to imaginary things. Okay, omega be the root of the equation x square plus x plus 1. And construct a polynomial fx, okay, within a degree where a0, a1 are all integers such that f of I plus w is 0. Okay, so this is the structure. Let me just recalibrate the question. So first we have an equation x square plus 1 that has a root that is I, and let omega be the root of another equation. So we need to construct a polynomial which is given in this format. Okay, so construction of a polynomial is our main motto here. Let's just add one page here. Okay, so how we are going to solve this? So we are given with x square plus 1 equal to 0. Another one x square plus x plus 1. Both are quadratic. Okay, and we have to construct the polynomial which will go to the nth one. Okay, so let's see here, the roots are I, here the roots are omega. Now omega plus I, if I just see this omega and I, these two, so omega plus I whole square is omega square plus 2I omega plus I square. I square equal to will be minus 1. Omega square is this, so 2I omega will be remaining same. So let replace omega square with minus omega minus 1, and this is 2I omega, and this is I square is minus 1. So minus 1 2 minus omega minus plus 2I omega. If I go for I plus omega whole to the power 3, then a plus b, a square minus ab plus b square. So in the one way we can write minus 2 minus omega 2I omega. Hence minus 2I minus I omega 2I square omega minus 2 omega minus omega square 2I omega square. So in this way we just recall 2I square is minus 1, so this will be minus 2 omega, and there will be another one. So doing all these things we can write there's omega plus 1, so that will also be replaced. So 1 minus 4I minus 3 omega minus 3I omega. So once we get it, so we can also calculate I plus omega. So my point is to get a common pattern, get a common structure. Okay, so this is also I plus omega, I minus 4I minus 3 omega. So this is by binomial structure. So I 4I square 3I omega 3I square omega omega 4I omega and minus 3 omega square minus 3I omega square. So this total together we can write I 4I square, so this is plus 4 minus 3I omega, this will be minus 3I omega I square, so this will be plus 3 omega. I'm just only writing the changes and there is no change here. So 2 omega plus 1 we can get it here, plus omega minus 4I omega and plus 3 into omega plus 1 and 3I into omega plus 1. So 7 plus 4I plus 7 omega minus 4I omega. So as a result of that, if we just put into this structure, so a0 a1 into I plus omega a2 I plus omega square a3, then I plus omega q and a4 I plus omega to the power 4. If we just put all these values, so a0 minus 2a2 plus a3 plus 7a4 plus a1 minus 4a3 plus 4a4 into I plus a1 minus a2 minus 3a3 plus 7a4 into omega, and the last one is 2a2 minus 3a3 minus 4a4 into omega into I. So equating all coefficients with 0, we get 4 equations. First, this will be equal to 0, this will be equal to 0, this will be equal to 0, and this will be equal to 0. So we need to find the integral solutions. So the integral solutions are, if you solve it, you will get a01, a1 equal to 4, a2 equal to 5, and a3 equal to 2, and a4 equal to 1. So obviously the answer is fx is 1, that is a0, then a1x, so 4x, a2x square, 5x square, a3x cube, and a4x4. That's the first question's answer. Okay. Now we get to the second question for this. In the second question, let a be a fixed real number. Okay. And consider the equation x plus 2 whole square into x plus 7 whole square. Okay. Plus a equal to 0 where x is real. So R is the set of all real numbers. So for what values of a the equation have exactly one double root. Okay, so 2 are from theory of equation here. Quite rare. So for this we have to go for a little bit of diagrammatic representation. So you must have, for this you can also check my classes on this. Okay, so we have an equation. Remember that we are solving the second question. X plus 2 whole square, x plus 7 whole square plus a equal to 0. Okay, so this has been given, and x is the set of real. Now, if this has been the fx, let's try out the first order derivative first, because in these kind of cases first order derivative is a prerequisite. You can also put this kind of structure into a functional cross checking via any graph based software as well, but obviously at the time of examination you don't have. But remember that it has 4 powers. Okay, so there will be power equal to 4, so 3 bending points, that's for sure. This curve will look like this or this, no sorry, or this. So 1 bending, 2 bending, 3, 1, 2, 3. So total power minus 1. So differentiation will help us to proceed to this level. X plus 2 square into x plus 7, a is constant, so 2 into x plus 2 can be taken common, x plus 7 can be taken common, and it will come up with 2x plus 9. Once this has been reached, so first order is obviously equated with 0, so x will give you value, this will give you minus 2, minus 7, minus 9 by 2. So now x equal to minus 7 and minus 2 are the roots of the equation gx equal to 0. So if we put it over here, so this will come. So for this equation fx we get the roots. These are the roots of this given equation. The equation has 2 roots. So double roots are done. So now value 9 by 2 is the root of the equation. Okay, so this 9 by 2 is the root of this equation. So fx equal to f of minus 9 by 2. Okay, so this will give you 5 by 2 whole 4, and this is the only double root of the equation. Hence, as this is the double root, so a is this value, and if we subtract this value, so this is a, so if we subtract this value, then only this equation will get to this level. So a equal to, sorry, this is plus minus of this thing, minus 5 by 2 whole to the power 4, that is what a is. So this is the answer to this question. Okay, so in the next video we'll be solving 3 and 4.